Hello everyone, we are from Group 3. We will present about report of observation of effect of light on rice weevil Staphylococcus aureus L. Our group is Yusuf Arifin with study number 54, Refido Arian Thohari with study number 56, Azotilo DT from Filipina with study number 19000076. Background: rice, Oryzae sativa L, is one of the most important staple foods in the world for human consumption. Rice storage is one of the post-harvest activities in the chain before the commodity is distributed. Warehouse pets, as Oryzae, can use economic losses in the form of quantity loss and quality loss, change in color and taste, decreased nutritional value, and contamination by dirt and insects' body parts. Warehouse pets carry out their activities at night. This indicates that pest is good at it at using dark light to make it safe for itself in carrying out all its activities. Rice, Oryza sativa, had two major subspecies in the sticky short-grained japonica variety and the non-sticky long-grained indica variety. Scientists have long debated whether the varieties reflect independent domestication events. Rice originated in China. A team of genome research has concluded in a study tracking back thousands of years of evolutionary history through large-scale gene sequencing. Their findings, which appear in the latest issue of the Proceeding of the National Academy of Sciences, indicate that domesticated rice may have first appeared as far back as approximately 9,000 years ago in the Yangtze Valley of China. Previous research suggested domesticated rice may have two points of origin: Indians, India as well as China. Pest warehouse. Commercial warehouse environment can be a challenge for the pest management industry. Add food stock and other perishable items to the mix and it can become even more challenging to manage pests in this space. Your pest management program will be customized to your specific warehouse or storage facility. This is not a one-size-fits-all program. Our management professional will take into consideration all entry points, food sources, water sources, shelters area, and other consideration all and other space within your facility to create a plan that will work for you. Special attention will be paid to exiting and possible problem areas and modification or sanitation. Recommendation will be made to eliminate conditions that may be conducive to pest activity. Proactive pest management is more effective than reactive pest management, and we work hard to eliminate pest problem long before they can become a problem. Rice weevil Staphylococcus aureus L. Scientific classification: Kingdom Animalia, phylum Arthropoda, class Insecta, order Coleoptera, family Cuculionidae, genus Sitophilus. Staphylococcus aureus is also called as rice weevil. Habit and habitat: Staphylococcus aureus is usually found in grain storage and processing plants. They infest with oats, rye, barley, rice, and corn. Sometimes they are also found infesting bean, sunflower seeds, and dried corn. These insects do not bite nor damage wood.
Okay, next is Refido Stopilus Orizae. Identification. WEEVILS have showing type of mouthpart. The most significant identification feature of the weevil is their snout, with brown in color. It has irregularly shaped bits on its thorax. Also, four-like spots are found on wings convert. Feeding habitat and development of rice weevil. Female drill a tiny hole in the grain kernel top which it deposits its egg substance. Inside the grain kernel, the eggs hatch into a young larva which migrate toward the center of the grain kernel. Now inside the grain, the larva feeds, grow and develop into a pupa. The pupa undergoes major internal and external changes inside the grain to develop into an adult. Emergence. The emergence adults are ready to mate the begin their generation. They may cause rice fever. Rice fever are the most destructive pests of stored grain and they completely destroy the grain. Attack is evidenced by surface heating of grain, dampness, which may even cause germination, presence of numerous adults. Next, control measures to avoid product discarding heavily infected material, repackaging material into a new infection-free container, place the production in the freezer for several weeks may help to kill adult and larvae. Next is a life cycle of SITOPHILUS ORYZAE. A single generation can be complete in 28 days, rest to body and remaining silent even when disturbed. This is a picture life cycle of rice weevil. First is egg to larva, pupa, and the last adult SITOPHILUS ORYZAE.
The life cycle of SITOPHILUS or Rizza. It is started with the egg, to larva, to pupa, and to adult. So the egg, rice weevil lays its eggs in crevices of kernels or dust. Female rice weevil lays about 4 eggs per day. During its lifespan of 5 months, it lays a total of about 250 to 400 eggs. The eggs hatch in 3 days. Larva, they feed inside the grain kernel for 18 days. The larva is the only stage during which the insect grows. Inside the seed, its cuticle hardens and matures. It consumes several times its own weight and periodically molts to increase in size. Pupa. The pupa stage lasts for 6 days. The pupa does not feed. In some species, the pupa is enclosed in a cocoon constructed by the larva. The pupa goes through great changes both internally and externally. Finally, the insect emerges out as a developed adult. In the adult stage, adults are between 0.1 and 1.7 centimeter long. They have 3 pairs of legs and their bodies are divided into head, thorax, and abdomen. Adults move and penetrate deeply into bulk of grains and get widely distributed. Head includes the mouth parts and sense organs. Thorax bears the legs and wings. Then the abdomen contains the reproductive organs. In our tools and materials, we use a small bottle and 100 grams of rice and rice slice or the SITOPHILUS or Rizza, 5 males and 5 females in our light treatment. In our working step, we fill each container with 100 grams of rice and 10 rice slice. A container of rice and rice slice in 3 places with different light intensities, the outdoor, indoor, and the dark room. So we observing rice slice population, the rice odor, the rice consistency, and rice color and the rice weight. So in this slide, this is the table of our observation results in light treatment. So you can review in our PowerPoint slide. Observation results. The color change to yellow in the outer treatment occurred at week 6. The color change to yellow in the indoor and darkroom treatment occurred at week 9. The color change of rice was fastest in the outer treatment. This is because extreme temperatures accelerate color changes in analog rice. The color change in analog rice is due to the fact that the manufacturer of BAJ does not use food additives in the form of dyes, but naturally from carotenoid pigments. The highest number of rice lice was found in the darkroom treatment, with 634 fleas, indoor as many as 502 fleas, and outdoor 84 lice. Darkroom is mostly due to the habitat of rice lice. The condition of the integrity of the rice in the outdoor treatment obtained the integrity of the slightly broken rice, while for the indoor and outdoor treatment, the intactness of the rice was obtained the floor. The rice beetle breeds in the rice for egg containers. Then the larvae get bigger and hit the rice grains from the inside so that the rice becomes hollow and easily broken.
Rice weight. The outdoor treatment obtained rice weight of 97 gram. In the indoor treatment is 87 gram of the rice were obtained. In the darkroom treatment, the weight of 78 gram. The darkroom weight is the like because in the treatment there are many lice, so the amount of rice consumed also increase. This is a documentation of the indoor treatment with granny. This is a documentation of high light treatment. This is a little of SITOPHILUS ORYZAE, or this documentation of low light or indoor treatment. This is many SITOPHILUS ORYZAE, and this is without light or dark room treatment. This is more many of SITOPHILUS ORYZAE from group 3, and thank you.